Welcome. We're going to solve this question before us, and it's one of those tricky trigonometric equations, and we immediately know that it's tricky because, as you can see here, we have a coefficient other than 1 for our x. As soon as you see that, you know that this is a tricky one. So the first thing that we want to do is we want to say let whatever this is, so in this case x on 2, be equal to just any other prime numeral. It could be anything. I'm just going to let it be equal to theta. And now I can rewrite this instead of x on 2 as negative 2 sine theta plus the square root of 3 is equal to 0. I can then rearrange this to make it 2 sine theta is equal to minus the square root of 3. And then I'll divide both sides by negative 2, which will make this positive. Perfect. Now I'm there. This is far better to deal with than what we previously had. So this right here is far better. The reason why it's better is because the coefficient of theta is just 1. That's what we want. We don't want anything else. All right, but before we can move on here, because we have changed it to be in terms of theta, we also have to get our domain in terms of theta as well. So how can we do that? Well, I've let x on 2 be equal to theta. So what I'm going to do is I'm going to make this x on 2. To do that, I'm going to times this by a half, times this by a half, and times this by a half. That means I'm going to get negative 3 pi on 2 is less than or equal to x on 2 is less than or equal to 5 pi on 2. Now, as you can see, what I have said is that x on 2 here, and I've got x on 2 is equal to theta. So that means I can replace that x on 2 with theta. So that means I'm going to end up with negative 3 pi on 2 is less than or equal to theta is less than or equal to 5 pi on 2. I can now just change this so I'm no longer dealing with inequalities. I much prefer to write it like this, but it's not necessary to do this. But as you can see now, everything is in terms of theta. And that's what we want. We want everything in terms of theta. So you have to alter your domain when doing these types of questions. Okay, now that we've got this, what are we next going to do? Well, now we just treat it like a normal solving trigonometric equation problem. We've got this, and now it's just business as usual. I would say that all of that preceding it, people normally find this part the tricky part. Once you're here, it's smooth sailing. We know how to approach a question like this. The first thing that we need to do is figure out what the reference angle is going to be. And hopefully you can just immediately identify that if we're dealing with sine of some angle is equal to the square root of 3 on 2, hopefully you can just immediately see that's pi on 3. If you're not able to do that yet, you can also look at your special triangle and say, well, I know that this is this. Because sine is opposite over hypotenuse, I know I must be dealing with this angle down here because this is opposite, this is hypotenuse square root of 3 on 2. So you can use your special triangle if you can't just immediately recognize that, but I think it's a very good skill just to immediately be able to recognize it. The next thing that we're going to do is we're going to consider which quadrants we're going to exist in. So if we just draw a little rough unit circle here and saying that we're dealing with sine, so that's our y, and the square root of 3 on 2, that is up here. So that means we're dealing with our first and second quadrant, our first and second quadrant. So that means the angles that we're dealing with are going to be what? Well, this is where we have to keep an eye on our domain to see what's happening with our domain here. Well, I know just looking at the positive ones, I'm going 5 pi on 2. So that definitely means that my first quadrant is included. So that's my reference angle, and that's going to be pi on 3. I'm going to write it over here, and actually I might do it in a different color as well. Let me just keep it with the blue. That will be pi on 3. I know that my first quadrant is going to be included. I know that my second quadrant is going to be included. So that's going to be this angle right here. That angle is just going to be what pi on 3 is in my second quadrant. And hopefully you can just immediately say, well, that's going to be 2 pi on 3. Memorizing those is really quite helpful. So now I've got 2 pi on 3. But now we have to think, well, what else does a domain of 5 pi on 2 include here? Well, to think about this, where is 5 pi on 2? Well, I know that 5 pi on 2 is simply 4 pi on 2 plus pi on 2, right? So this is simply 2 pi plus a half. So that means, if I get rid of this, I'm going once around for 2 pi, and then here. So hopefully you can see my angle that also is going to be included is that one right there. So what I've drawn there in red. To get that, what I'm going to do is I'm simply going to plus 2 pi onto pi on 3, because as you can see, it's just 2 pi plus pi on 3 there. What is pi on 3 plus 2 pi? It is going to be 7 pi on 3. So this will be 7 pi on 3. If you need a hand figuring that out, all I did is I know that pi on 3 is 6 pi on 3 plus pi on 3 is 7 pi on 3. That's an ugly 3. So I just got my 2 pi as a denominator of 3 there. All right, let's get rid of that. Perfect. Hopefully you can appreciate that I can't go any further. I cannot go any further because I know that, that right there, that's 5 pi on 2. So I can't go any further. If I go any further, I go beyond my domain. That's really important. If that part kind of freaks you out a bit, you need to come and have a chat. So we can just work out the domain with you. Okay, we continue. Let's get rid of this, that. Okay, and of course we're going through this a lot slower than what you would do on a test. You would have to go through a lot quicker in this in a test. Then we've got negative 3 pi on 2. Negative 3 pi on 2 is going backwards, and it's going backwards by that amount, because that right there, what I've drawn is negative 3 pi on 2. So hopefully you can see the next angle we're going to have to consider is that. And to get that angle right there, I'm going to have to take, I'll do this like this. I'm going to have to take 2 pi on 3 and subtract 2 pi from it. And that will give me that one right there. What is 2 pi on 3 minus 2 pi? It is going to be negative 4 pi on 3. If you needed a hand doing that, you could just kind of come over here, do some rough working. That, remember, 2 pi is the same as 6 pi on 3. So that's negative 4 pi on 3. That's how you're figuring that out. Negative 4 pi on 3. Okay, not pretty, but we're doing it. Okay, now this is, again, one of the tricky things as well. Because our question was given to us in terms of x, our answer must be in terms of x. So how are we going to resolve this? So to get our answer in terms of x, what we're going to realize is that, hey, I know that, what is theta? Theta is simply x on 2. So that means if I wanted to, and again, this would be taking it too slowly in a test, you would have to do a lot faster than this. But what I could do is I could just say, well, x on 2 is simply going to be equal to this, because I know that theta is x on 2. Negative 4 pi on 3, pi on 3, 2 pi on 3, 7 pi on 3. If I now want to get x by itself, how will I do that? Well, I'm simply going to times this by 2 to get rid of it. And that means I need to times each of these by 2 as well. So that means what is my final answer going to be here? It's going to be x is negative 8 pi on 3, 2 pi on 3, 4 pi on 3, 14 pi on 3. Now we can highlight that because that, actually I might put a red box around it, that is my final answer. I've gotten everything back into x. Now hopefully you can kind of think through ways you could do this quicker. Was this line really necessary? Maybe not. Maybe I could have just timed all of these by 2 instead of rewriting it all. So I'm going through this slowly just to make sure that everyone's on the same page. But obviously in a test environment, you're going to have to work quicker than what I'm working here. Hopefully you found this helpful, and make sure that you reach out if you find anything here confusing. See ya.